draw C and D, so I'll do that. Let me just close this. Okay. Just wait for the writing pad. Drive anywhere nice for your break? Where?
This around Dublin.
Oh, that's not nice. You didn't leave Dublin?
Yes, I leave Dublin.
Where?
On Friday, Galway.
Oh, well, that's nice.
With the college.
In your car?
No, with the college, in the coach. I can't drive on motorway.
Oh, of course. Of course, yeah.
Why?
Because the license he has to do the test before he can.
But I mostly go from my good people home.
Yeah, he's a bad driver. Bad. Right, C is this way, and D is like this way. And the question was a half C minus a half D. Well, if that's C, then this would be a half C. If that's D, then this is minus D, and this would be minus a half D.
Yeah.
So then there's a half C, and there's minus a half D. If you add them together, it's messy, but you get this vector squished in between them like that. Yeah. And that's the answer then. Yeah? You want to write that down? Okay. So then we'll start the next lesson now. How far did you get in these?
3.
Okay, that's fine. Yeah, yeah. Adnan?
1, 2.
You think? Yes?
2.
Oh, 2?
2 and 8.
Okay. Right, next. If you want to write it down, it's called Euclidean vector. What, Adnan? English, please. Great. Euclidean vector. You can write this down. Miss Sharif, you must be hot because you don't have your coat on. Would you like me to open the window more?
No.
Are you sure? Hey, it's the first time I've seen you in class at 9 o'clock without your coat on.
No, it's not on.
No? Okay.
First time, yeah.
Second time, maybe.
Yeah, close.
Yeah. Okay, do you write that down? Euclidean vector. So this is something you haven't done in physics. So this is completely new now. Okay. So one problem with vectors is it's kind of a pain to draw them. You know, this is vector x, this is vector y. It's a bit of a pain. So we have this thing called a Euclidean vector. And the way they work is first you must have some points. So for example, if you have something like a square, I'll just call this point A, B, C, D, and we'll put the point in the middle as M, like this. And I'll draw it in the square, though I don't have to. You can make vectors from these points. So when you write something like AB with an arrow here, what that is, it's the vector with a tail at point A, yeah, and a head at, hang on, and a head at point B. So this is the vector AB, like this. So actually you don't have to draw it, because it's clear what you mean when you say AB. It means this vector here. Okay. This I call this a Euclidean vector, although I don't really think that's the name of it in the books, but I wanted to give it some name to make it different in your head to what we were just doing. So when I write vectors in this form using 2 points, I call that a Euclidean vector, but it's still just a vector. Okay. So let's look at what we can do now. If you could write this one down, and then we'll have a look at some questions then. I need to get new ink. Yeah?
Yeah.
Okay. So let's have a look here. So what's interesting is you can now say things like vector AB, that's the same as vector DC. Because AB points east, DC points east, and they're the same length. How do I know they're the same length? Well, because it's a square. Yeah. So I could say AB equals DC. Also, I could say AD, what's that the same as? BC. Yeah. What about this one, minus AB? Yeah, but give me something more interesting. No.
BA.
Yeah, it's the same as BA, yeah. Which is also the same as CD. Can you see? A minus AB is BA, which is the same as CD. Yeah. Now, this is where it gets more useful and more interesting. You could say something now like AC is the same as AD plus DC. That you could say that this vector is the same as this one plus this one. Or the other way, yes, you could even say it's the same as AC is the same as AB plus BC. In fact, you could even say AC is AD plus DB plus BC. That A to C is the same as A to D plus D to B plus B to C. What's great about the Euclidean vectors is that it's like they're a path, you know. If you want to go from A to C, you can do that by going A to D, D to B, and then B to C at the end. You have many, many ways of writing it. Let's have a look at this M in the middle though. You could say AM is the same as what?
BM.
AM you could say is the same as not BM, totally not.
MB.
MC. True.
Why? What's the direction?
Well, here's AM and here's MC. It's the same vector. Yeah? But there is another vector you can say it's the same as. I wonder if you can see.
Half AC.
A half AC. Because it's half the length of AC. Yeah, you had your coffee this morning? Yeah. Really? Well, maybe the cigarettes are holding you back.
No.
Yeah. Maybe if you quit, you know. So it's the same as a half AC. Yeah. But you could also write that as a half AC is the same as AD plus DC,
Washington.
indeed, which is a half AD plus a half DC. So, you know, you could say AM here is a half AD plus a half DC. Add these two together. In other words, I'm trying to get you to see that you have so many options here when you write vectors in Euclidean form. Okay, so this was more of me just messing about, showing you the basic ideas. We'll have a look at an actual question now. We'll do it together. Okay. Do you need to write anything down from this?
Yeah.
Okay. I mean, you don't have to write all of this down, but maybe you want to write a couple of the interesting ones down that you found difficult. Like, for example, this one here was probably a good one as an example. Okay. Now you have it, yeah? Yeah. Let's have a look at an example. So, we'll do number 1 together as practice. Draw a rectangle of base 2 and height 1. Okay, let's draw that first. So, height is 1 unit and the base is 2 units. So I'll just put little points here to show this is 1 unit, this is 1 unit, this is 1 unit, this is 1 unit, this is 1, and this is 1. Okay. Label each vertex A, B, C, D, starting in the lower left and moving anti-clockwise. Anti-clockwise. A, B, C, D. Let M be the midpoint of AB. And let N be the midpoint of BC. Express each of the following in terms of AB and AD. So, AB and AD. I want to write all my vectors in terms of these two. So I'll give one as an example. A. So AC is the first one. And we want to write AC using only these two vectors, AB and AD. Okay, so let's have a look at AC, A to C. Okay, well I could say that's just A to B plus B to C. Now, AB, this is good, but BC, not good, because we want AB and AD. But if you look, BC is the same as what? AD. So you could write this as AB plus AD. And now, you've written this vector as 1AB plus 1AD, so to speak. You've written AC in terms of AB and AD. Okay. So we'll do some more together, but this is our first example. So if you can write this one down. You got that?
Yeah.
Okay. Before I give you the answer, see if you can figure it out. The next one I'll do is AM.
Half AB.
Write it down, see what you can get. And remember, I still want AB and AD.
Do I have to use both?
No, you don't. So AM, I think you can, you can see it already. It's a half AB. Okay, actually that was kind of an easy one for you. C now, let's see C. AN. Alright, try AN for me. See what you can get there. Again, not so difficult.
AB, half AB,
Yeah, AB plus a half
AB.
BC, but then BC needs to be changed. AB plus a half AD. Okay, I'll let you try this last one by yourself then. Don't say anything, just write it down and then we'll see if you get the right answer. MN. That's a much more interesting one. MN. You finished it? What did you get, Mary?
Half AB plus half AB.
Yes, that's it. So let's have a look here. So MN, that's the same as MA. Now there's many ways to do it, this is just one way of doing it. MA plus AN. Can you see that? MN is MA plus AN. Is that part okay? Yes? Now, MA is the same as minus AM plus AN. Now the reason I did that is because we already have an answer for AN. What is it? It's the answer to part B. And and we already have an answer for AN. It's the answer for part C. So this is equal to minus AM, which is a half AB, plus AN, which is AB plus a half AD, minus a half AB plus AB, what's that? Yeah, a half AB plus
Half AB.
oh, I lost my half here, sorry. A half AD. And that's the answer there for that one. Now, you didn't have to do it that way. In fact, if you look at the picture carefully, you could see that this part here is a half of AB, and this part here is a half of BC, which is the same as AD. Yeah. But for more difficult questions, it becomes harder to see that. So sometimes it's convenient to look at the previous answers to get the answer. Okay, so did you write this one down?
Yeah.
Yeah? Yeah. So the good news is it's only the first question where I made you draw, because questions 2, 3, 4 and 5, I give you the picture. So number 2 is just a square. Number 3 starts to get more interesting. Does anyone know the name of this shape? All 6 sides are the same?
Diamond?
Not diamond, no. Good try though. No? Does anyone know this shape? I don't think you would. Hexagon. H-E-X. Hexagon. You know this?
6. B13
Oh, hexagonal structures of carbon? Yeah. So you do know hexagon. Number 4 is not any particular shape, it's 2 triangles. And then number 5, 2 squares and What do we call this triangle that has the three sides the same?
Three sides the same.
Oh, there's a word for that. Huh?
First question in frequency.
Was it this?
Yeah.
I don't remember that.
Which one?
Oh, the thing hanging from the ceiling. Yes, I remember now.
Slide?
No, number one. It was a 1 meter, a 1 meter, and a 1 meter. Yeah, I remember now. It's called an equilateral triangle. Equilateral. Yeah, no, I know that. Okay, so for the exam, they're not. I mean, this is as difficult as it gets in the exam. These are all exam questions. In fact, they're not going to be as hard as some of these. So if you can do these, you can do this on the exam. And I don't think this is too difficult. What do you think? It's all just about... Yeah, it's all just looking at the picture. Yeah. So if you can try number 2, will be okay. Number 3 will start to get harder then. I'd like you to try and do 2 and 3 before you go today. So if you can have a look at number 2. If you want, you can draw it here. I'll just zoom in. So in this case, I want AB and AD again. I'm going to draw it. You do know what these little arrows here mean, do you, or not? I don't know if you did them in middle school. No, not direction. Not direction. Same what?
Same length?
No.
Parallel.
Yeah, when you draw these arrows like this, it means you're saying they're parallel, and this one here you're saying are parallel. And then when you put these lines, same length, yeah. And then what about here when you put the dots? You're saying that everything with a dot is the same angle. So like this angle is the same as, this angle.
So that means the length is also length?
No. All I've told you here is that the angles are the same. I haven't said anything about the length. Now, if you think about it, if these 3 angles are the same, then it's an equilateral triangle, which means then the 3 lengths have to be the same. But if this length is the same as, because these 2 triangles have a common side, and these 3 are the same, it means these 3 must be the same as these 3, which means these 3 are the same, and then all of a sudden everything's the same then, yeah. But I never actually said that they're the same length in the picture. It was enough for me to tell you that they all have the same angle. Yeah. Okay. I just wanted to make sure you knew that. So if you can try this one here. Maybe if you do this one and then we can check the answers together. How are they going? Which one are you on, EF?
Yeah, okay.
Are you finished? Alright.
D.
Which one?
D.
D? Okay. Mir?
C.
Oh, chop chop. Come on. I'll just give them 2 more minutes and then we'll have a look at the answers you got. Your answers match up?
Oh.
Okay. Mishri?
Last one.
Last one, okay. Yeah. Yeah? Okay, let's have a look. So the first one, CD, what did you get?
Minus AB.
Minus AB, very good, correct. DB,
Minus AD plus AB.
D
Yeah.
plus AD.
minus AD plus AB.
It can't be
Yeah.
A plus AB.
No. No, because I said I wanted AD,
Not D.
not DA. AC,
AB plus AD.
yeah, AB plus AD.
S.
AM,
Half AB.
half AB plus a half AD. And then CM,
Half AB minus half AB plus minus half.
yeah, minus a half AB minus a half AD. Yeah.
Can you do it again?
Say it again? Yes.
A.
C, which one? CM?
A.
CD minus
A.
Minus AB.
Yeah.
Wait, hang on, you want me to say all the answers again?
It's only 5.
A minus AB.
Thank you, Edna.
B minus AD plus AB. C
Minus what? AB.
plus AB.
Uh-huh.
C AB plus AD. D half AB plus half AD. E minus half AB minus half AD.
What's D? Minus what?
A1.
Minus
D.
AB minus AD is same as
D
AD minus
half
CD.
AB plus half AD.
Minus a half.
Minus
And
AB
D?
minus AD
Minus
Yeah.
half
is equal to
AB.
AB plus AD.
minus
Or not?
I don't know, I don't think so. You'd have to swap the letters. Like minus AB is the same as BA. Did you get that, Miss Sharif?
I did the sign wrong.
Okay. It's okay now? Good. So the next one now is starting to get harder. This time I want AB and AF. AB and AF. AB, AF. So that's this vector and this vector. Okay, see what you can do with this one now. AB and AF, yeah. You can't quite see it, but that letter in the middle is an X. So what are you looking at first? BC, is it? Yeah. I'll give you a little hint for the first one to get you started. BC is the same as what? Yes, true, but that's not really helpful here. BC is the same as AX. And now AX is maybe easier to deal with than BC.
This is like BC 2AB.
No, no,
Why?
because that's wrong.
Why?
2AB is a really long vector, yeah.
Plus AF divided by.
What is BC? And it's AB and AF.
That's what I'm asking.
So it's AB. Same as AB.
No, it is not. Definitely not. AB is pointed northwest and BC is pointing northeast.
It's also. BC is there.
BC is the same as AB.
No.
AX.
No, he just asked me that. Mir, tell him why it's not.
Because, direction.
Not quite what I said, but
No, the direction like of BC is different and AB is different. It's going, Mashriq. It's
It's the same as AX.
yes, yes.
I think it's equal to FE. BC.
Yeah, that's what he had said, but that's
You
not
don't
what I
want
want. I'm looking for in terms of AB and AF.
AB and AF.
Is it AB plus AF?
It is, thank goodness. Because AX is the parallelogram of AB plus AF. Yeah. Okay. Now we're starting.
How AB plus AF? How?
Because the parallelogram law, AB plus AF, when you draw the parallelogram, is AX, which is BC, yes.
That was smooth.
And it barely took 3 minutes to get. Okay, so once you have that, the next one now is CX. Now that one's actually not as hard, believe it or not, if you can see it.
DA?
But
Minus AB.
minus AB, yeah. XD is next. X is in the middle.
CX.
Which is, you couldn't have forgotten already, AB plus AF. It is.
What is CX?
CX is minus AB. AD now.
2AB.
2AB plus 2AF, yeah.
Yep. Now we're getting there. Two AF, yeah. So I told you it gets a little bit harder, but it's not that bad, right? Yeah. Okay. Can we scroll down to the next one then? Not yet. Yeah. Okay. So next now, let's see. Voila, indeed. Right. the other thing you need to note is I say, guys, look, the vector xc is the same length as xd, so xc and xd are the same length. The vector xa is 4 times the length of xd. So this one is 4 times bigger than this one, and this is the same length as this one. And the vector xb is 3 times bigger than xc. So this is 4 times bigger than this. This is 3 times bigger than this, and these two are the same. I know it doesn't look like it. Right, so find AX in terms of AD. Okay, so AX in terms of AD. So what?
3 over 5 AD. Yeah.
No. Yeah, what's it going to be?
4 over 5.
times bigger.
Yeah, so what would be the answer then for AX?
3 over 4. 4 over 5.
4 over 5 AD.
Yeah, which is a 3 over 4, 4 over 5. 4 over 5. 4 over 5 AD. Because AX is 4 units and XD is 1 unit. So AX is 4/5 of AD. So the first one is 4/5 AD.
Yeah.
So BX has a similar logic.
Straight answer is no.
So BX would be
3
3/4 BC.
3 over 4 BC?
Yeah. Yeah. Okay. AD in terms of AX. Yeah, so AD in terms of AX.
AX plus 1 over 5 AX.
Well, if you want, what was your answer you got for A?
4 over 5.
4 over 5
AD.
AD
Yeah.
equals AX, wasn't that it?
Yes.
So by just rearranging, you can say AD equals 5/4 AX. Yeah, yeah. No, I just wanted to show you the logic there. So 5/4 AX is the answer here. So 5/4. So then, what's the next one? I ask you the same type of thing.
4 over 3.
4 over 3. Yeah, 4 over 3 BX.
Find AB.
AB. Now, this is where, remember earlier I said sometimes you can see it from the picture and sometimes you can't. You have to use your previous answers. So AB here, you can't, there's nothing for you to compare it to. You will have to say something like AB is AX plus XB. Yeah. Now that's okay, because you have these. This is AX is the first one.
4 over 5 AB.
The answer for A. Yeah, I'll just write A for the moment. And XB,
Minus 3.
it's minus the answer for B. So that's minus the answer for B. Okay, what was your answer for A?
4 over 5 AD.
And the answer for...
3 over 4 BC.
Now, do you get what I'm saying? There's no way you would have been able to get that from just looking at the picture. That's the reason I gave you these parts, is to help you think about how to get the last one. Do you understand? So this is hard if I don't give you these. It's because I had you do this first that made this last one a bit easier. Okay. So in the exam, maybe they'll help you by breaking it down, or maybe not. And they'll just have a question like this. You'll have to figure out yourself how to get there. Yes. Okay, did you write this one down? Yeah? Oh, sorry, is it? Okay. Hang in there. We've only got 3 minutes left.
Yeah.
Can I scroll down?
1 second, please.
Yeah. Yeah? Adnan?
Yes.
Okay, there's the last one. So I won't help you with this one. If you can get this one finished, and then you can go then. And then there's no homework. So if you can try and get this number 5 finished now. BA and BC is what I'm looking for.
Half BA plus
Which one are you looking at? C is very hard actually.
No.
It's equilateral.
Yep.
DE is the same as DF.
It is not.
What? Not the same.
DE is not the same as EF.
Why is D half? D is the same as DH, which is the same as half AB plus half AC.
Hang on, I missed what you're saying. Why is DE and EF different?
Why are they different? Isn't it equilateral?
Yeah, they're the same length, but they're not the same vector.
Oh, it's not the same.
But the DE is the same as DH here.
No, because what angle is this? 60. True? So what angle is here on the ground? 30. What angle is this?
9,
No, just here to here.
45.
45. Are those the same angles? So although they look it, they're not pointing in the same direction. One is pointing at 45 and the other one's pointing at 30. So unfortunately DE is not the same as BH. If it was, your life would be easier.
DE same as IF.
DE is the same as IF, no, for the same reason.
So DE isn't similar to anything.
Exactly.
So we need previous answers.
No, not this time.
We don't need previous answers.
Well, I didn't help you that time. For this question, I made it harder by not giving you any hints to get to the answer. Interesting, huh?
I think
What is HI?
AB, I think it's
BC.
Same as
HI is the same as BC.
Yes.
Do you want a little hint for DE? Yeah? I recommend for DE going DB, going this way from D to B, then go halfway up, and then go all the way to the right. So that isn't as bad as it sounds, because D to B is minus what?
2 BC.
2 BC. And then here to here is
half
a half
B.
BA. What about here to here?
2 half BA.
2 BC.
2 BC.
Yeah. So the only thing you need to work out is how long is it from here to here, because this is not a BC. It's actually shorter than BC. Well, this is what you need to work out, and it's not, I don't think it's half BC. So you'll need to use a little bit of sine cos tan, a bit of trigonometry. I think this will be a good one to leave for homework.
Yes.
Yeah.
Yes.
Yeah.
All right.